Okay, today we want to do a quick review, and remember, we're not going to do everything that's we've taught you so far. We're going to do the highlight, the biggest ideas, things we want to make sure that are on your actual cheat sheet or your help sheet that you're going to create for the test. Okay, so we're going to start with our first unit, which was chemical reactions. In chemical reactions, you were required to, after we learned how to balance and do names and that kind of stuff, you're required to predict reactions for the products. Okay. But before you can do that, you need to remember all the categories. So there was synthesis, decomposition, and then there was single replacement, and then there was double replacement. And if you remember, each one had their own distinct way that they looked. Synthesis was more like using two elements, and they would come together. Decomposition is when you have a compound that is torn apart into its two components that make up the elements that make it up. And then single replacement is where you have an element, something that's by itself, attacking a compound and trying to replace one of those elements. And so you might end up with A, C, and then the element B has been replaced and set free, okay? And then we have double replacement, which is A, B, a compound attacking another compound, and it ends up being a swap of ions. And so what happens is A attaches itself to D, and C attaches itself to B, and you get a new reaction, okay? And so remember, you're then going to be using these types of categories to figure out what these products could be after you've categorized it. So not only do you have to categorize them with the products, if you don't have the products and want you to predict them, you will not have these end products. And so you have to be good at predicting based on categorizing them without the products. And then you'll have your predicting packet that we're going to give you. You can use this. We will supply this for you for the test, but you do need to know how to read through it and follow the rules properly, okay? So don't forget about how to use that. Make sure you've used it. Try it out a few times. We gave you some problems, some simple problems to try. You should be able to do that. Remember also, within this thing, anytime you have an element, there are 7 elements we call them the 7-ups and that kind of stuff. They're the 7 elements that actually, when they're in these formulas, they have a 2 by them because they're part of that group of 7 elements, like hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, okay? So 7 of them have to have a 2 by them if they're all alone in a balanced chemical equation. So that is one area that you do need to know, so don't forget about that. Also, remember that there are also little subscripts or little pieces of information that you can add. We can tell you that there's maybe heat involved, maybe there's going to be in a chemical reaction, so A plus B going to C and D. Maybe you need a certain element to be a catalyst. Maybe you want to know if the materials are solid, liquid, or gas. Remember AQ, remember it's being dissolved in water. So there may be questions on those categories, those ideas as well. Okay, so don't forget about that. And then the last thing I want to remind you of in the chemical reactions review is also there are different things that indicate that there's been a chemical change, and there is color change. So color change are indicators. We put them over here for you. We'll call them indicators. Oh, we forgot also one more category, didn't we? Before I go back, we'll put down here combustion. We just talked about it a minute ago, and I didn't even put it down. And combustion is when you have a hydrocarbon and oxygen, and they always form CO2 and H2O. So I apologize. We want to make sure you know that category too. You'll have to predict those as well. And so that's also one of your categories, but it is also in the packet, okay? And so indicators. Indicators are things that happen that can tell you, that lets you make sure that there was a change in the actual reaction. It's because something that was brand new has been made. There's a brand new color to the material, like when iron rusts. It's silver when it's iron, but then when it turns rusty, it's like an orange color. We have a temperature change, things that give off heat, okay? Some of you have actually mixed baking soda and vinegar. You form a gas, okay? Bubbles are formed. And so those are great indicators that a chemical reaction has occurred. Also a precipitate, okay? And a precipitate is just when you have like liquids in a solid forms, or you have two gases put together in a chemical reaction in the liquid forms. It means a change in state, okay? And so those are the biggest indicators to help us remember that there has probably been some bond breaking in the chemical reaction, okay? So make sure you know your categories, make sure you remember how to predict the products using the sheet, and make sure if you don't know the ions, because remember you're going to be putting things together by ions. If you don't know your ions, make sure your ion sheet is rewritten onto your help sheet, okay? Because we're not going to give you that in the test, okay? So from there, we're going to go on to the next category. The next category was called molar conversions. So conversions and stoichiometry was our next category. And what that was about changing materials using the mole idea. So we had our flow chart, and you all remember that. We had volume, mole, particles, and we had mass, okay? And each jump had its own unique bracket. It was a conversion bracket. This one was formula weight or molar mass, we'll put it there. Molar mass over 1 mole. This one was 6.02 times 10 to the 23rd. You had 3 different names. Ions were also a particle. Atoms were a particle. Formula units were a particle. And molecules were particles. So we had those categories over 1 mole. And this one was also 22.4 liters over 1 mole. But the restriction was, we learned in the gas chapter, that this has to be at STP. And so you'll have those ones where you can use volume. So the mole conversion part of the unit or test is when you're changing materials from one name to another name. So we taught you how to do that. You write down, you had 4 steps, you write down the given number, you then count the number of jumps you're going to go through, and then fill the bracket, the one you want goes on top, and then you solve. And when you're all done, you end up, your given number here, you end up with so many jumps, and then you end up cross multiplying and deleting all the units, and the unit you want is left over, okay? So don't forget how to do that mathematics. Practice it, remember your 4 steps. I would write a chart down with the 4 steps, but with this unit also came 2 different kinds of problems. They were called empirical formula and also percent composition. And empirical formula was when we gave you materials and we said, well, based on so many grams of carbon, we had so many grams of carbon and we had so many grams of oxygen, could you figure out what the carbon to oxygen ratio was? And we gave you the 4 steps. Remember the 4 steps were you convert the mass into moles, and then from the moles you divide by the smallest, and then if you divide by the smallest you get a ratio, and that ratio turns into a formula. And so please make sure you review those steps and do those problems, okay? Because there's a couple of those on the test as well. And so we have empirical formula. We also have percent composition. Percent composition was ones where we actually take the formula weight, and you show the formula weight, you divide each of the elements by how much they contribute to the formula, and you find the percentage of each one. So percent composition, if I did it really quick, for water, we know, if we want to find the percent that each one contributes to water, we know that water, first of all, you find the formula weight. And we know water weighs, we have 2 grams of hydrogen, we have 16 grams of oxygen, okay, 2 times 1, and then we get 18 grams total. The second step is you divide each by the total. So I'm going to divide 2 by 18 and 16 by 18. That gives you a decimal number, and then you multiply by 100 to get a percent answer. So this gives me 0.111, this one gives me 0.888. And so what happens is When you then times by 100, this tells us that we have 11.1% of hydrogen makes up the weight of water, and 88.9% of oxygen makes up water weight. So that's percent composition. So those kind of problems will be on the test, and they come from the conversion, mole conversion part of the unit, okay? So don't forget about those. Make sure you write them on your sheet so you have them as a help. You can even put some example problems on your paper. That'll work out real well too. The next category within this test is, of course, the stoichiometry chapter or unit. And that one was when we used a full flow chart. So you had a balanced equation. So A plus B going to C plus D. And then we said, hey, they say they give us 10 grams of this material. How much liters of that one? Maybe they might ask you how many moles of this one. They can ask you any question they want, but if you're going between two materials in a balanced chemical equation, then what happens is you need two full flow charts. And what you do then is you have to cross over for the two flow charts. You then now have to cross in the middle, and when you cross anywhere in the middle, you're going to need to use the balancing coefficients. And what happens is then your middle jump has the coefficients. Remember, the one you want goes on top. So if I'm going to go from grams to volume of B, let's just say I labeled them randomly. Here's A, here's B, okay? And let's say I want to go from 10 grams. So I mark the gram box in my A chart. I mark the liter box in my B chart. And I can pick my direction through the chart. But either way I go, there's 1, 2, 3 jumps. So I'd write down my given number. I would put my 3 jumps next to it. And then I would start filling in the chart. Remember, mass to mole, mole goes on top. And then the formula weight of A, so we'll just say formula weight A. And then you're going to make the jump across the charts. So remember the coefficients, so it's going to be the one you want going on top. It's 3/2. So now that gets me to another stoichiometry or another mole conversion chart. Then I go up to volume, 22.4 liters over 1 mole. And of course, moles would cancel out, the formula weight, grams would cancel out, and then the liters would be my last unit. And so I just would do the math. Remember, everything on top is multiplication, everything on the bottom is division. Okay, I want to talk about the other last two types are limiting reactant, okay? And limiting reactant is where they give you 2 reactants. And so let's say they give you 20 grams of one and 10 grams of the other, and we ask you which one is limiting, which one's going to control the reaction. So what you do is you take both of them to the same answer, and it's usually always grams, and then you do the 2 math problems side by side, okay? So you have your 10 grams and your 20 grams, and then what you do is you follow all the math through. You got to relabel the charts, do all the math, and then you're going to get 2 answers. And let's say that this answer works out to be 14.5 grams of C, okay? But this one works out to be 11.3 grams of C. So what that tells us is that this one is actually going to limit the reaction. You're only going to make that much material. So A would be the excess reactant and B would be the limiting reactant. So we're going to give you problems like that to think through. And then there's also percent yield. And percent yield is not hard. Percent yield is, they tell you, well, hey, maybe you actually are going to produce, you could have produced 12.5 grams, but you only got 11.3 from your experiment. Or I should say, forgive me, let's just say that this is what you could make, but you made 10.8 grams. And so percent yield is an equation that's written as your actual yield divided by your theoretical yield. And theoretical yield is what you theoretically can make from the stoichiometry math from a flow chart. So 11.3, and then of course 10.8 you then would multiply by 100, and it works out to like right around 92.3%. So it means you were 92.3% of theoretical yield, okay? So make sure you have these formulas, make sure you have a couple worked out in your help sheet so that you know what's going on when the question asks, okay? So that's what you're going to be required to know for stoichiometry.